Imagine this. Everything has stopped. The universe is approaching absolute zero. Atoms no longer vibrate, energy fades, motion disappears. According to physics, this is the point where everything should freeze. But somewhere, something is still moving. At Lawrence Berkeley National Laboratory, researchers did something extraordinary. They stacked atomically thin layers of materials, and something strange emerged. Like overlaying transparent sheets with patterns, these layers created a wavy, mesmerizing design called a Moiré pattern. But it's more than just a pretty image. On the atomic scale, this pattern becomes a landscape of energy, filled with hills, valleys, and ripples. And within those ripples, live special particles, interlayer excitons, an electron and a hole, stuck in different atomic layers. They fall into the Moiré valleys, and they're supposed to stay there. Physics says they should be trapped. But here's the twist, they're moving. How? Because the energy landscape, the Moiré pattern itself, isn't standing still, it's moving. And this movement is caused by something even more mysterious, a quantum quasi-particle called a phazon. A phazon is like a ghost wave traveling through a crystal, not a particle you can hold, but a coordinated movement with real momentum and energy. And it seems to ripple through the Moiré landscape, making it dance ever so slightly. As a result, the excitons trapped in the valleys begin to surf this quantum sea. In the words of lead researcher Antonio Rossi, the interlayer excitons are surfing the Moiré. The phazon acts like a surfboard, carrying the excitons forward. And the most astonishing part, this movement doesn't stop, not even at ultra-cold temperatures, below -150 degrees Celsius. In a world that should be frozen solid, the particles keep drifting. It's a tiny motion, but one that shouldn't exist. It hints at a completely new way to transfer energy and information in quantum systems, a new pathway to protect delicate quantum states from falling apart. This discovery isn't just beautiful, it could make future quantum technologies more stable and more powerful. And while the team hasn't caught the phazon red-handed yet, they see its footprints in the ripples, in the motion, in the soft, whispering waves of a landscape that should be still. Even in a frozen world, something moves.